Hello and welcome to the HVAC 101 module for valves. In the HVAC industry, we use many different types of valves. This presentation is going to cover some of the most common types that we use to control flow. The valves can be ordered either at NPT, which is National Pipe Thread, to join with threaded pipe. They can be sweat connections, which is another term, as we know, for solder connections, or they can be connected by a flange that utilizes bolts. All valves will have markings on them indicating their usage and pressure ratings. The markings are WOG, which stands for water, oil, gas, can be used for water, oil, or gas, but not steam. Then you have another marking that could be WSP, which is working steam pressure, or you could have SWP, steam working pressure, or simply an S. These markings indicate that the valve is okay to use with steam. After these markings, you will find a number, usually 125, 150, 300. That is the actual maximum working pressure of that valve. You cannot exceed that pressure, otherwise the valve could fail. Regardless of type, all valves have the following basic parts: the body, the bonnet, the trim, which is actually the internal elements, the actuator, which is a motor that could open and close the valve, or a handle, which can be used to manually open and close the valve. And most valves also have a packing. Packing is used to seal between the handle and the actual body of the valve to prevent water or oil or gas from coming out, depending on what it's being used for. The packing material of valves can be widely varied. It could be Teflon, O-rings, graphite cord, or some of the material that when compressed seals between the shaft and the body of the valve, preventing leaks. As valves are used, the packing may start to leak. This leak can be stopped typically by just tightening the flange or the packing nut, which are generally located under the handle of the valve. When it is tightened, or they are tightened, it compresses the packing material, thus stopping the leak. At some point in time, though, it may not work anymore because the packing is fully compressed. And at that point, the material inside the packing gland will need to be replaced. Packing material comes in different... The valve shown in this picture is a ball type valve. These valves are great for on-off operation to isolate a device in a piping system. They can also be used to throttle the flow of fluid. Throttling means to adjust the rate of flow through a piping system using a valve. Although it can be used to throttle, it is a poor choice for this application in that the valve's characteristics prevent fine control of flow. When the valve is open, the handle will be parallel to the pipe. When closed, it will be perpendicular. Ball valves can be ordered sweat, NPT, or flanged. It can come full port, which means the hole in the valve's ball is the same size as the pipe it's installed in, or reduced port. That means that the hole in the ball will be smaller than the pipe which is installed in. A full port ball valve will have basically no pressure drop over it. Pressure drop is when a fluid flows over a device and it causes restriction, so it drops the pressure over the valve. So basically, the full port will have no pressure drop, whereas a reduced port will have some pressure drop, but is a lot cheaper than the full ported valve. Like I said, these valves offer excellent shut-off capabilities. They're quick to turn on and off. They can be mounted in any position, but they are not well suited for throttling situations. The valve shown here is a butterfly type valve. This valve is also used to control flow of fluid through a pipe. The valve is made up of a body, seat, disc, stem, and an actuator or a handle. Operation is similar to that of the ball valve, which allows for a quick shutoff. The disc is positioned in the center of the pipe. Passing through the disc is a rod connected to an actuator or handle on the outside of the valve. Rotating the actuator or the handle turns the disc either parallel or perpendicular to flow. A butterfly valve is from a family of valves called quarter-turn valves. In operation, the valve is fully opened or closed when the disc is rotated only 1/4 of a turn. When the valve is closed, the disc is turned so it is completely blocking off passage of the fluid. When the valve is fully open, the disc is rotated 1/4 of a turn so it allows almost unrestricted passage of the fluid. This valve may also be used to be opened partially to try to control or throttle the flow of fluid, but like a ball valve, is not well suited for this application. The valve shown here is a flange connection valve. Some advantages of a butterfly valve are its compact design, requires considerably less space compared to other valves, it's very light, and it's quick in operation for either opening or closing. The disadvantages are that the throttling service of the valve is very limited. These valves actually, are called gate valves. They operate by lifting a round or rectangular gate or wedge out of the path of the fluid to be controlled. Gate valves are primarily used to permit the flow of fluids. A typical gate valve should never be used for throttling purposes, only for on and off. Throttling will cause premature valve failure. Gate valves have either a rising or non-rising stem. Rising stems provide a visual indication of valve position. Because the stem is attached to the gate, such that the gate and the stem rise and lower together as the valve is opened and closed. Non-rising stem valves travel up or down the stem on threads, without raising or lowering the stem. Non-rising stems are used where vertical space is limited. Some advantages of gate valves are very positive shutoff for flow, so they work real well on and off. They have very low pressure drop, but the big problem with them is they're no good for throttling, and they're also slow to open and close. The valve shown here is a globe valve. These valves are used for regulating flow in a piping system. Globe valves have an arrow imprinted on the body telling which way the direction of flow should be for the valve to operate properly. Globe valves are named for their spherical body shape, with the two halves of the body being separated by an internal baffle. This has an opening that forms a seat onto which a movable disc or plug can be screwed in to close the valve. In globe valves, the disc is connected to a stem, which is operated by screw action using a hand wheel and manual valves. Globe valves are used for applications requiring throttling, flow control, and frequent operation. Since the baffles restricts flow, they are not recommended where full unobstructed flow is required. Globe valves are normally installed so that the pressure is under the disc. This contributes to easy operation and helps protect the valve's packing. For applications with high temperature steam, globe valves are installed so that the pressure is above the disc. Otherwise, the stem will contract upon cooling and tend to lift the disc off the seat. Stop and waste is a feature that can be added to globe valves. The valve has a male threaded port on one side with a cap. The port is useful when installed on the outlet side of the valve when the valve is in the vertical position. When the valve is turned off, unscrewing the cap opens the port, allowing the pipe above to drain the fluid out. The picture on the right is of a stop and waste. Some advantages of globe valves are they have very good shutoff capability. They're very good in throttling situations, but one of the problems is they also have a high pressure drop and they are slow to open and close. The last type of valves that we're going to talk about today are check valves. They are designed to only let water flow in one direction. The valve on the left is a swing check, which relies on the force of water trying to flow backwards to force the disc to seal against the seat, thus preventing water from flowing backwards. If the flow of water is forwards, the disc will move off the seat, allowing flow. These valves, when mounted in a horizontal line, the bonnet cover must be in the upright position. If they are installed in the vertical line, the direction of flow must be up. Otherwise, the disc will just kind of hang around in there and wouldn't seat up. This type of check valve offers very low pressure drop, but it does have installation limitations. The picture on the right is of the inner workings of a spring check valve. This valve can be installed in any position because the spring will force the valve closed whenever the flow of fluid stops. These check valves can be installed in any position, which is a really good advantage, but have a higher pressure drop than a swing check.